All right, guys, in number 5, it says which of the following power functions is shown in the graph below, and then to explain our choice. What we could do is we could put these all into y equals, and we could pick which one matches the graph more closely. But that's not the idea of this question. The idea of this question is to use the characteristics that we talked about on the front and be able to pick our choice without having to graph it. All right, but if we were ever unsure, we would graph it. So the very first thing I notice is that this has the same end behavior. Both ends are doing the same thing. They're both going down, and therefore I know that that same end behavior refers to an even degree. And so as soon as I know that, 7 up here is not even, it's odd, and 9 down here is not even, it is odd. And so choice 1 and choice 4 would have opposite end behavior, not same end behavior. So I'm stuck with choice 2 or choice 3. And the only difference between choice 2 and choice 3 is that choice 2 has a negative leading coefficient, whereas choice 3 has a positive leading coefficient. And because these ends are both going down, I know that that refers to a negative leading coefficient. Okay. And so I'm going to go ahead and go with choice 2. And if I really wanted to make sure that my choice was right, I could go ahead and go to y equals and type in negative 3x to the 10th and hit graph and see if my picture matches what my calculator screen shows me. Okay. Down here, just a little bit of a review of something we talked about earlier in the year called even and odd functions versus even and odd degree, which is what we talked about today. All right. There is a way of proving even functions. However, this year we cut that part out. So we're going to skip that part because I didn't teach it to you. All right. We did talk about seeing whether a function is even by graphically, whether it was symmetric over the y-axis. Okay. We also talked about opposite inputs having the same output. Okay, so that's what an even function is. And now we have to remember that even degree is somewhat related in that the fact that we use the word same, but even degree functions have the same end behavior, like in the question up above. All right, whether both ends are going up or both ends are going down. All right, so that's even degree versus even function. Okay, whereas when we talk about odd functions, okay, we could prove them algebraically, but again, I cut that part out this year for the sake of the year. But to prove them graphically, we talked about them being symmetric over the origin, also known as a rotation around the origin of 180 degrees, meaning that it looks the same upside down as it does right side up. We also talked about opposite inputs having opposite outputs. Okay. And now we are going to talk about odd degree in that we still kind of use that same opposite word, but to remind ourselves it's opposite end behavior. Behavior. I spelled that completely wrong, so let's try that again. Behavior. All right, so opposite end behavior will look something like this, where one end is going up and one end is going down, or vice versa. This one's going up and the other end is doing the opposite and going down. Okay, so that is the difference between odd functions and odd degrees. Okay, all right, but they are similarly related. Okay, and so in number 6, we're going to go ahead and try to tie all of that together. And so in 6, it says for the functions below, determine if they are odd or even degree. All right. And when they talk about odd and even degree, they're talking about either the same end behavior versus opposite end behavior. Okay. And so taking a look at our 4 graphs, let's go ahead and do part A in all of them. So in number 1, these should technically have arrows here, and they are doing the same thing, both ends. And so this will be same end behavior, and same end behavior means even degree. Okay. Whereas in part A here of the second graph, we have one end going down and one end going up, and that's opposite end behavior, which is what we call an odd degree polynomial. Okay. In the third graph, we have our ends both going down, so they have same end behavior, and same end behavior is an even degree. Okay. And in part A here of the last graph, one end is going up and one end is going down, and therefore that's opposite end behavior, and that would be an odd degree. All right, let's head to part B. Part B is asking whether it is a positive or a negative leading coefficient. Okay, positive leading coefficients end going up. Okay, ends going up. Okay, whereas a negative leading coefficient would ends going down. Okay, and when I say end, I'm talking about the right side of the graph. All right, so taking a look at our first one here, that end on the right side of the graph there is going up, and therefore this would be a positive leading coefficient. So positive leading coefficient. Okay, in part B, look at how it ends. That ends going up, and so this would also be a positive leading coefficient. Okay, in part B of the third graph, that ends going down, and so this would be a negative leading coefficient. And in the very last graph, this ends on the right-hand side here going down, and down would be a negative leading coefficient. Okay, part C is asking whether it's an odd, even, or neither function, and this, when they don't talk about the degree, odd degree, even degree, they just talk about odd or even, they're talking about the symmetry of it. All right, so symmetrical over the y-axis would be even. A rotation of 180 degrees or symmetric to the origin would be an odd. All right, so in part C here, we can see that this graph, if we fold it along the y-axis here, I think you guys can see that the left-hand side, when folded over the y-axis, matches up with the right-hand side. And in this case, this would be what we call an even function. So not only is it an even degree, it is also an even function. Okay. In part C here, guys, you can see that the y-axis would not be a line of symmetry, and therefore it's not an even function. Okay. If we rotate our paper upside down to see if it's symmetrical over the origin, or it looks like a rotation of 180 degrees, it would look like the right thing, same exact graph right side up as does upside down. You're going to say no to that. It is not going to look the same upside down as it does right side up. And so this would be what we call a neither function. All right. So even though it's an odd degree, it is not an odd function. Okay. And in our third graph here, some people will say it is symmetrical over the y-axis, but take a look right here, guys, is that turning point there is not right on the y-axis, and therefore you guys can see also right here that on the right-hand side, it intercepts at 3, but here it does not intercept at -3, it intercepts at -4, and so it is almost symmetrical to the y-axis, but not exactly, and therefore this would be a neither. And so even though it's an even degree, it is a neither function, okay? It's not an even one like the very first graph. So not all even degrees are even functions is what this is trying to get you to see, all right? And then the very last graph, obviously it's not symmetrical over the y-axis. Okay, both sides are not doing the same thing. And so we're not going to say that this is an even function. So now we have to decide if it is symmetrical over the origin, or does it look like a rotation of 180 degrees, meaning that if I turn my paper upside down, will it look the same right side up? And the answer is yes, it will. All right. And so that this is an odd function. And so not only is it an odd degree, it is also an odd function. Odd degree meaning it has opposite end behavior, and an odd function meaning it is symmetrical through the origin. All right. Whereas graph number 2 was an odd degree, but it was not symmetrical through the origin. And so it was neither. All right. So you guys can kind of see the difference between even degree, odd degree, and even function and odd function. All right. That just because you're an even degree doesn't mean you have to be an even function. Okay, you have to have that same symmetry in order to be. All right. So let's go ahead and take a look at the third page of notes, because we do have a third page, and I'll see you guys in that one.